Hi students, coming to our next topic, that is instruction code. So what do you mean by this instruction code? Instruction code is nothing but it is a group of bits. A group of bits, you call it as instruction code. Means they're in the form of ones and zeros like that. So instruction code is a group of bits that tells to the processor to perform some specific task. It says to the computer to perform some specific task. So whatever the task is, it just saying to the computer to do some work. So here every computer has its own particular instruction code format. So whatever the computer you're taking, they are having their own instruction format. The simple way to organize the instruction code by using with two parts. The instruction code can be organized into two parts. That is one opcode and next one is the address. So the complete instruction code will be divided into two parts. One is opcode and another is address. So actually from where we are getting this instruction code? In the memory, the instruction will be present. So from the memory we are getting the instruction code, and that we are going to be converted into group of bits, and that group of bits will be read by the processor. So actually this memory will be the size of 4096 into 16. So this is the size of the memory for the 16-bit instructions. So this memory will be divided into two parts. So one holds the instruction program, and another will holds the operand, that is the data. So memory is having instruction program and then is operand data. So here actually this instruction code is of size 16-bit because it is having 4096 into 16 memory location. So this instruction code format will be divided. It is a 16-bit address from 0 to 15. So in this 0 to 15, 4096 means this is a 2 power 12, and 16 means 2 power 4. Means here the 12 bits specifies this 12 bits specifies the address part, and this 4 bits specifies the opcode. So the instruction code will be divided into two parts. One is address part and another is opcode. So here the 4 bits will specifies the opcode 15 to 12, and the remaining 12 bits 0 to 11 will specifies the address part. So this is the instruction format. This is the instruction format. Okay. So actually this instruction is of three types. It's a memory reference instruction, register reference instruction, or IO reference instruction. So this instruction which we are getting from memory, or we can get from a register, or it is of IO. So whatever the instruction that will be is of three types: memory reference instruction, or it is a register reference instruction, or it is a IO reference instruction. So based on this instruction, the processor will understand what type of instruction we are getting. So this instruction is coming from memory reference, or it is from register reference, or it is from IO reference. Okay, so actually this instruction code can be of three types. Means it can be it is in the format of like immediate address, direct address, indirect address. So this instruction holds opcode and address. So this opcode and address will be of immediate or direct or indirect. So based on the instruction, the processor can understand the instruction which it gets is whether it is immediate data, or it is a direct data, or it is an indirect data. Immediate means it specifies actual operand. So actual operand will be present in the immediate address, means opcode and direct operand. So this is 0 to 11, 12 to 15. So this is the immediate address. Opcode and operand, direct operand will be present. So then the processor understand this is an immediate address. So we are just getting the operand and it calculates the operation. Now coming to the direct address. So what this direct address specifies? Direct address specifies the address of operand. Address of operand. So we call it as an effective address. Effective address. So direct address holds the address of the operand. Here in this place 0 to 11, if address of the operand is present, then we call it as a direct address. Means just suppose this is a memory location. So which I said here, this is an instruction program. Instruction will be present. So this instruction may be, suppose add suppose 430. This is some memory location. So in the particular 430, you are having the actual operand. Actual data will be present. So this is the memory location. So in that memory location, the instruction will be like this: 0 add 430. 430 here indicates the address of operand. So this is the address of operand. So where this address in this 430 location, you are having the operand. So here the 0 indicates it is a direct address. So this is direct. So in that particular address of operand, in this 430 is address. In that particular address location, you are having the operand. This is the effective address. You call it as a direct addressing. Now coming to indirect addressing. Indirect addressing specifies the address of memory word. So it specifies the address of memory word in which address of operand is found. So first it holds the address of memory word. In that particular address of memory word, address of operand is present. Again you have to go to that particular operand. So it's look like this. So this is the memory location. So but if it is an indirect addressing, you have to keep it as 15th bit is the I1 at 430 20. So in that particular 430 location, you are having the address of the operand. So again you have to go to that particular address. There you will find the actual operand. So this is the indirect addressing. So this is the instruction. In this instruction, indirect address means address of memory word is a 430. In that address of memory word, in which there is address of operand will be found. So here the address of operand is 1250. So in the particular 1250 location, you will find the operand. So this is the indirect addressing. So these are the different formats of the instruction code. Thank you.